Every software team pays taxes. Every rushed release, workaround, missing test, and we'll fix it later decision becomes part of a hidden bill. At first, the bill feels small, the product ships, the roadmap moves. But over time, those shortcuts start charging interest. Features take longer. Bugs become harder to trace. Releases slow down. New hires struggle with systems that should be simple. Eventually, the team is not scaling software. It is scaling complexity. This is the technical debt tax. Technical debt is the future cost created when a team chooses a faster solution today that makes the system harder to change tomorrow. Sometimes debt is intentional. A startup may need to launch fast and prove the market. That trade-off can make sense. The problem begins when debt is not tracked. Temporary fixes become permanent systems. Documentation disappears. Ownership becomes unclear. Testing becomes optional. Dependencies become fragile. At that point, technical debt is no longer a tactical choice. It becomes the operating model. Rapid scaling creates pressure. More users, more features, more integrations, more developers, and more deadlines. Under pressure, teams patch instead of redesign. They copy code instead of creating shared services. They build on unstable foundations because rebuilding would slow the roadmap. In the early stage, this feels efficient, but systems are connected. Poor database design affects performance. Inconsistent APIs affect integrations. Missing tests affect every release. That is how technical debt compounds. The first shortcut saves 1 week. The 10th shortcut costs 1 month. The 100th shortcut changes the culture. The technical debt tax is the ongoing cost a company pays because its software is harder to maintain, modify, and scale than it should be. It shows up as slower velocity, higher defect rates, longer onboarding, more incidents, and reduced innovation. A feature that should take 2 days takes 2 weeks because developers must work around old decisions. Fragile areas break whenever someone touches them. New engineers need extra time because the architecture is confusing. Engineers spend more time keeping the system alive than building what customers need. Technical debt quietly consumes payroll, delays growth, and weakens competitive advantage. To calculate the cost, translate technical debt into engineering capacity. Ask, what percentage of the team's time is spent on maintenance, bug fixes, incidents, deployment issues, and cleanup? If you have 10 engineers and each costs $150,000 per year, that is $1.5 million in annual capacity. If 40% of their time is spent fighting legacy systems, your technical debt tax is $600,000 per year. Now look at feature cycle time. If a feature used to take 1 sprint and now takes 3, the codebase is charging interest. If estimates keep expanding, the system is resisting scale. Also, track deployment frequency, lead time, defect escape rate, and mean time to recovery. These metrics answer the real question: how much of our engineering budget creates new value, and how much pays for past decisions? The breaking point happens when maintenance costs eclipse new feature development. You may see roadmap items delayed again and again. Simple features require many changes. Developers avoid risky parts of the codebase. Bug fixes create new bugs. Customers complain about performance or reliability. Leadership may hire more engineers, but output does not increase. When debt is high, adding engineers can create more coordination overhead, duplicated work, and inconsistency. The goal is to make debt visible and manageable. Create a technical debt register. Track debt items like product work. Include the affected system, risk, business impact, and cleanup effort. Classify debt by severity. Some code is ugly but stable. Other code blocks revenue, security, or product velocity. Connect debt to business outcomes. Do not say, we need to refactor this service. Say, this delays onboarding by 3 weeks. Dedicate capacity to repayment. Rapid scaling can be powerful, but speed without structure creates a bill that eventually comes due. The real question is this: are you using debt to grow faster, or is debt now controlling how fast you can grow? If your team spends more time maintaining the past than building the future, the tax is already too high. Measure it. Prioritize it. Repay the debt that blocks growth. The most expensive code is not always the code you write. Sometimes it is the code you keep carrying.